Okay, so here's this big liquid nitrogen tank. Wow, oh, holy delay, Batman. Okay, and then there's some level here, and there's some pressure here above this liquid, which is P naught, right? It's not always an atmosphere. It could be a higher pressure in this case, right? And this is very typical. You do this with liquid nitrogen. You have a pressure there so that you can, make it go into equipment and stuff like that. And this is 13.5 meters. This is 808 kilograms per cubic meter. Okay, and so we want to know, there's an absolute pressure at that depth, right? So we're going to go pressure is pressure above the fluid plus rho GD, right? And we want to figure out what that pressure is above the fluid. The absolute pressure is 313.7 times 10 to the third pascals, right? That's what kilopascals means, right? Is the thing we're trying to find plus 808 times 9.81 times 13.5. So there's our depth is 13.5. Okay. I don't want to be out of my depth here, but there it is. Okay. So 313.7 E3 minus 808 times 9.81 times 13.5. And I get 206,692.52 pascals. But we want to know what it is in PSI, right? So let's turn it into PSI. So I'm going to divide by what atmosphere is in pascals, multiply by 14.7. So divided by 1.013. Stupid lights. Okay. E5 times 14.7. And I get 29.99 because I engineered this problem, okay? I know for a fact that in big dewars they keep this at 30 psi. They have a regulator because this stuff always is boiling. You can't exert enough pressure to keep it from boiling. So it's always boiling away gently. It depends on the insulation here. And then we just have a little pressure regulator here that lets it off if it gets above 30 psi. And then you've got 30 psi is a good pressure for piping this stuff out. You can send it someplace. In the case, I had a summer job after high school where we used liquid nitrogen to cool down pressure sensors so you could make sure they worked when it was 20 below. That's cold.